Swayam Prabha. Digital India. Educated India.
Hello and welcome to this sixth lecture on this ESG analytics and green finance. Today we talk about the science of weather risk measurement, indices, indexing, managing how uncertainty will be managed. So primarily we'll be looking at what are the various risk measurements, what is the role of artificial intelligence, GIS, blockchains in this area. What are the various climate indices we're going to be looking at and the role, and finally what is going to be the impact on the financial aspects of various financial instruments we are looking at in this area of risk measurement and climate and ESG and analytics around it. So let's try and go ahead and see what we do. My name is Atul Tripathi and I am an honorary adjunct fellow at National Maritime Foundation. So why measure the risk? The first question first is about how and why should we even bother to measure the risk? The risk is because you see 1 degree of global warming will increase annual disaster costs by 25%. That's a huge jump you're looking at, 25% jump in the natural disasters. Now we're seeing what is happening in Uttarakhand where landslides, cloud bursts, overflowing of the rivers is causing not only damage to lives but huge damage to property as well. So there's a complete chaos on the happenings in the Himalayas. We've seen a few days back earthquakes in Kamchatka, resulting in huge problems across the world, particularly on the east and the Pacific Ocean, on both sides of the Pacific Ocean. So 1 degree rise in the temperature is resulting in 25% losses as per Swiss Re 2023 reports. And that does bring to the NatCat losses over the events. If you look at the catastrophic losses that have happened, is about $320 billion across the world. And if you look at various places, so you see there are hydrological events and there are climatological events and then meteorological events and also geophysical events which has happened across the world. So like, the wildfires in US to Hurricane Milton in US to flash floods in Germany and Poland and Austria and Czech Republic, overall losses resulting in about $5 billion, to insured losses of about $2.2 billion, to flash floods in UAE, where you're looking at about $8.3 billion over losses and resulting in about $2.8 billion of losses in insured losses, I would say, and fatalities about 38 people. That's the kind of nature of losses and the information that is being floating around. So that brings us to the question is, what is a weather risk in measurements? It's about quantifying the likelihood and the financial impact of the climate-driven events we're looking at, such as storms, droughts, floods, earthquakes, all kind of stuff you're looking at. And primarily it's around hazard, where you're looking at severity and the frequency. Cyclone speed effects, speed winds being one of them, exposure to assets, supply chain disruptions, financial instrument disruptions, what is happening in the people's lives, destruction in the people's lives, cost in terms of medication, hospitalization, vulnerabilities and sensitivity of those assets to damage. Without measurements, this risk and underpricing will be a huge losses to the financial institutions and the governments at large. So why do we need to measure? The first is financial stability, because it is preventing you sudden losses because of pricing climate linked disruption into business and investment decisions. Insurance and hedging is another one, enabling the parametric insurance and the weather derivatives to protect against volatility. Capital asset allocations, funds toward climate resilient infrastructure and nature-based solution. Regulatory compliance, which we have been talking over and over again. And most importantly, the strategic advantages, because once you can quantify the weather risk, you can outperform the peers in terms of resilience and vulnerability, how to overcome the vulnerabilities altogether. Now, we've been seeing some of the areas, examples such as HDD or heating degree days or CDD, cooling degree days. We saw about a couple of lectures ago. We discussed in detail regarding this thing. The severity drought index, which we discussed in the last lecture. Then flood risk scores, the cyclone tracking probability models are some of the various examples that are as far as the weather risk models are concerned. It is here that the role of artificial intelligence and GIS, logical information systems are becoming very, very important because it is providing a spatial decision making, overlaying of the hazards with the various assets that have been located over various time places, various places across the globe, and stamping around it. The changes that are happening, the AI will bring in the prediction and the predictability of these technology will be bringing in these things. So the weather risk measurement actually is about uncertainty. It's about in turn bringing uncertainty into a strategy towards various financial goals or the life-related goals that we need to take care of. Without a robust metrics or businesses, the governments can price risk. They cannot price risk, rather protect the value and unlock the capital funding that is required to in this regard. What about the forecasting to foresight? That's where the game begins to change, and that's where the rule, with the application of artificial intelligence and GIS, the entire weather-related risk measurement systems begin to change, because the AI is able to predict what could happen, while the GIS is giving you where it is going to impact mostly, and they are transforming your weather risk from statistical guess to financial action frameworks and approaches that one needs to take care of, because you're able to bring in predictive analytics, because since there is a lot of machine learning insights that you can get from data sets, satellite images, forecasting, synthetic event generations. You can using generative AI is becoming very popular. So Black Swan is one that is being created because the generative AI approaches the climate scenarios to stress test the test portfolios, dynamic financial modeling, and as far as GIS is concerned, it gives you the asset level precisions. We are able to map your hazard zones, floodplains such as floodplains, cycle tracks, wildfires, against specific insured or financed assets. What about the exposure verification in terms of remote sensing, validating against the physical triggers, cascading of the risk visualization is another important aspect. So GIS plus AI, that's the new paradigm we are looking at, a complete shift where you're integrating your risk indices, which AI is consuming as a part of the GIS systems, when there's a layering of location-specific climate scores. Then you have real-time parametric insurance, smart contracts based on the blockchain technologies, forecasting, GIS verification of the threads, capital market allocations is one thing. So let's look at some of the platforms that are very popularly available on the internet. If we'll just go back to one of the popularly available, like this is one of them, WRI Aqueduct Tool. So here you can go around, play around with the multiple platforms. So let's take the case of Aqueduct Weather Risk Atlas. So if you can go here, you can check what is happening. So you have the physical risk, overall risk that you're looking at. What about the physical risk quantification, physical risk quality you're looking at, regulatory and reputational risk, something we had discussed some time ago as well. Interesting. So if I take the water risk stress, I can just check where it is happening, what's happening. So let's play around with this tool. As we see that, we can see what is going to be happening around here, the changes that are happening, the temporal changes accordingly. You can also see where this entire game is going to be. And another one is earthdata.nasa.gov. This gives you a complete worldwide view with it's an interactive interface, and you can get full browsing resolution, global and daily satellite imagery out there. So here you can see they've been powered by various GBIS, global imagery browse services, which are very popular and very powerful tool. Here you can go and launch the worldwide view. You will get a complete access to these tools. You can see what is happening. So here it is being launched all over again. It's being launched. So here you can clearly see. I will just cross this thing. You can see the impact on if I was to just play around with the coastlines factors, you can add layers, you can start comparisons, you can play around with the various time zones you're looking at. You can see that as it goes by. So what is the impact when you start looking at it? You can start adding layers and layers over information over it. You can, based on your air quality index, let's play around with this, and then you can immediately add, and it brings you a complete change in the transformation. As I said, again, in terms of your timelines, it's as precision as the daily to even hourly levels we're looking at. So these are the new kind. And also very important thing is data is very important out here. You can clearly see what kind of data has been fixed around, what kind of near real-time data they're looking at. So it gives you a complete kind of precision. You can set an area of interest and you can download your Earth data searches as well. So if I take this into consideration, it can give me a complete view If I just continue with it, it gives me a complete view around it. So that's the kind of platforms now that is being developed around, and it is giving us a very, very clear view of the very classical use of artificial intelligence with GIS, and where you're looking at measurement of forecast, from forecasting to foresightedness is what we are looking at as a complete game change thing that is taking place, because AI enhanced weather models are improving the disaster losses estimate by about 40%, and GIS based asset mapping is reducing the underwriting uncertainty by 30%. That is as per Swiss Re 2023 reports, and that's why it becomes very important for all of us to understand this game. And therefore, another point that we need to look at is, how do you monetize your data? Data needs to be, it's the main key out here. The data is what is called money or oil in today's world, because AI and GIS do not only measure the weather risk, they monetize with it with the precision, while it is enabling your parametric insurance and catastrophe bonds to become faster, cheaper, and more reliable as a climate resilient tools. Because traditionally the challenge has been in terms of basis risk, the payouts don't always match with the actual future losses that have happened, particularly in the case of poor indexed regions that you're looking at. It's here that the role of artificial intelligence becomes very, very important, because using historical and your climate data, you can model your the parametric insurance with the higher probability distributions for various kind of hazards such as cyclone, earthquake, flash floods, to name a few of them. You can correlate between the hazards and the financial losses so as to optimize your threshold limits and trigger how will your triggering of the threshold limits will be taking place. Something we have discussed in the past as well. The AI's role in terms of catastrophe pricing bond model, something we have discussed regarding the how you can have simulate thousands of climate change adjusted hazard scenarios to improve your probability of loss estimates, and the deep learning processes of the satellite imagery so as to assess evolving exposure in terms of urbanization and deforestation. GIS role in terms of asset mapping and concentrations on ports and grids and cities, linking it with the intensity to bond payout triggers so as to reduce my mispricing that may have taken place. One of the case studies that has come around is about $500 million flood-linked cat bond in Southeast Asia priced using AI modeled rainfall prediction plus GIS exposure systems that was mapped, and then you could attract about 15% lower spread. That is what we are looking at. So your blockchains, AI, GIS, this has become the new triad where the blockchain is actually automating your payout once the factors are triggered around, and you can immediately settle it through smart contracts, reduction in time payouts, more precision in terms of the payout to the concerned parties concerned, whether it's human individual levels or the institutions at large or even the governments, and so that's where, it's about monetizing it with more precision rather than anything else, and that's where the world has moved towards. That brings me to another point, and that is again beyond forecasting. What can we do? We can quantify our synthetic risk in terms of the resilient resilience of the finance and the ESG strategies, because only 8% of global disaster losses are captured in traditional forecasts. And the systemic risks remain vastly underpriced. That is as per the World Bank 2023 report, because predicting the next storm is not enough. What matters is understanding how one event can cripple the entire balance sheets and supply chains of the societies. That is what is becoming an important point, because shifting from forecasting events to quantifying synthetic risk is allowing the businesses and governments to transform the ESG from compliance checklist to a true resilient strategy we're looking at. And that's very important, because you're able to provide hazard-centric data very specifically, use of forecasting, synthetic risk quantification in terms of connecting with the financial networks, infrastructure dependence, and ESG exposures. The systematic risk matters because in terms of finance, infrastructure, and ESG strategies. That brings me to another of these tools, Again, this wri.org, aqua.tools, you can just go and look at this, one of the platforms out here. So again, when we look at it, we can look at the crops. Let's say the case of a crop case, and you can play around again. You can say, take one of the crops, say, let's say the case of banana, and what is the weather in terms of water risk we are looking at. Say we are looking at the water stress, or say water depletion. What about the food security demand? Let's take the total crop production. How will it be impacted across the world? And we can see very clearly when we play around with this So it very clearly states that the total crop production, thousands of metric tons, the total crop production represents the total, and how will you enable this entire food production? How is it going to change the entire game? Similarly, you can look at other crops, coconut, say water depletion, or let's take a case of coastal eutrophic changes, and let's take the net crop trade. What is going to happen? You can check the time frames starting, you can play around with these time frames. You can check around with these, see that which areas are going to be the most highest impacted in terms of the changes of this thing. Top 10 countries with the highest coconut drought risk scores, you can look at it. So India becoming one of them. So agriculture drought risk score that gives you about 3.88. Bangladesh is the second one, 3.73. Then there's Cambodia, then there's Philippines, then there's Haiti, and then there's Dominican Republic, there's Indonesia. These are very countries that are very dependent on these kind of platforms. Also, if you look at the global percentage in terms of coconut production by water risk, what is the impact that is having on stress? So what is stress integrated when you're looking at it in terms of the production? How is it going to change from low risk to all the way to the extremely high risk? Seasonal variability because of the rain-fed factors that are coming into picture. What about your coastal eutrophication, potential triggered irrigated water problems? So you can look at these platforms. These are very good ones as a learners, extremely very good approach that needs to be taken. So you can also look at, once we look at these things, we can also look at on the ground, on the map side. As I said, it's not only about your use of artificial intelligence, but also GIS, which is giving you a complete clear map regarding the use of technology with the AI prediction. So here across the world, when we look at it, these are main coconut producing centers across the world, and that's where the challenges are. If you look at it in Bangladesh and India are the main ones that are going to be there, and similarly in Southeast Asia, as I'm hovering around the screen, you can clearly see the challenges that are emerging. These are the hotspots. Sri Lanka becoming one of the biggest ones, and that's where these kind of platforms, I would suggest all the participants to go and check it out and see what you can play around. This gives you a very clear-cut understanding of the data, the approach, the tools. You can start building something around it as well. That brings me to another point, and that is about the use of climate matrices and how do you building blocks around it. What do you do about these climate matrices? How do you handle this situation? And where is it becoming important? Because 90% of the global financial assets are not exposed to at least one climate-related metric, and fewer than 30% of firms are integrated into a decision-making system, because there are temperature-based problem statements based to precipitation-based to extreme events, long-term events. And then we look at various kind of energy-related problems, catastrophic bond pricing to agriculture insurance to real estate valuations. And each one of them is dependent on the kind of metrics that one needs to look at, so as to build it up. So climate matrices is no more about environmental statistics. They are actually financial signals which are trying to shape your asset pricing, investment flows, and ESG credibility, because climate metrics are actually quantifying the measurement and they're trying to capture the patterns, the trends, the anomalies in weather climate, so as to provide an evidence that is based on certain baselines for ESG disclosures, for risk pricing and financial structuring all the way. And, again, the integration of AI and GIS becomes a very important point, because, as I said, about forecasting the events, creating synthetic climate scenarios using generative AI in today's world, mapping it out with the various asset level platforms to blockchains where it's auditable of the records, to enabling trust in green bonds because the parametric insurance being triggering out. That brings me to another set of, very popular I would say these platforms like PSL, NOA, Gov. This gives you a good climate indices, which is less. And then let's look at some of them. And when we look at out here, see this thing? This gives you a complete climate indices. What is happening out here is it's giving you an indicator of what kind of climate prediction centers we're looking at, to all the way down to North Atlantic Oscillation. You can go to any one of them websites, so that give you a time series estimation you can look at. This is the kind of data that you will be getting. So that's a very popularly used data. You can download them, you can play around, build your own models on these data points. If you want to visit these sites, they're very popular, say Global Mean Land and Ocean Temperature Index. If you look at it from 1948 till down here, that gives you a very clear indicator, and it's as good as 2024. So that's pretty, I would say good one. And then we can come down and play around on the same website. We can come down and play around with these climate indices and monthly atmospheric, say, let's take the case of monthly atmospheric pressure series, ocean time series data. You can plot it out either on line plot, or you can give a box plot. So based on your time series data, say SOI oscillation index, and if we put say 1948 to say 1999, how does it look like? You can do a plot series, and let's say how does it calculate and give you a complete plot series around it. So Southern Oscillation Index, SOI, from this to this, and you can also download your data files. How does it look like? And that's the various ways of playing around with these platforms. Another very popular platform is NCEI. Again, if you go here, you can look at the mapping tools. This is the climate data we're looking at. This website gives you a complete data sets, is what is important out here. Here you get a complete list, while here you get a complete data sets. Anybody who's interested in these kind of websites can look at the tools, various data tools that are available. You can play around with it. Again, you can download it. You can even procure it based upon your budget. Then you have the mapping tools and the search tools as well, which is giving you complete understanding. So let's let this open up. So you have maps and geospatial products. So you have your marine geological data. Let's see how it looks like. One of the data sets that we're looking at. See, yeah, it comes around. So you can see marine, say if I say do a marine geological data set reports, and I say give me the details, here it is. So it gives you how the entire marine data logic created across the world, you see, which are the various hotspots. Then NOS seabed description of it. You can also open it up and you can see the seabed description of the hydrographic surveys that have been happening at various places. Let's just open around, see that? And they're mostly been happening around this specific oceans area. A lot of activities is still taking place. So a pretty good website to play around, a pretty good, I would say, these are very good areas to be there on these websites. I would suggest a highly recommended one from my side. Please go here and check out all these factors. So as we go ahead, we look at some of the matrices on the climate side, and one of the matrices that we look at is the drought matrix, which is about quantifying the scarcity of climate resilient finances structures. Because 90% of the global financial assets are exposed to at least one climatic changes or metrics, and 30% of your firms are being integrated into the decision making as per NGFS. Some of the parameters or the factors that is taken into as far as the drought matrix is concerned is standardization of precipitation index, which needs to be calculated, which is your rainfall anomalies with the historical averages, because it is impacting your drought index crop insurance altogether. Then you have Palmer Drought Severity Index, PDSI, which is about soil moisture and evaporation of the balance, which is talking about your water resource planning, sovereignty drought bonds that are there in the financial terms or financial instrument terms. Standardization Precipitation Evaporation Index, SPEI, temperature adjusted drought severity is what it measures, and it's looking at climate change adjusted agriculture hedging of the funds. Then you have Streamlined Drought Index, which is talking about SDI, hydrological deficits that are there, and your hydrological risk management, ESG water metrics that are there. These are some of the very, very important parameters that one needs to understand before one goes to understand the drought metrics, because it's about tracking your duration, the severity, the spatial extent of the droughts. How will you price your agriculture risk? How will you design your parametric insurance? How will you do your structuring of the drought-linked bonds? That is what is becoming very, very important, because again, the financial implications are immense in terms of the parametric insurance. So any payout which has been triggered by SPI is less than -2 for the consecutive 3 months is where the parametric payout begin to take place. Then you have drought-linked catastrophe models, where the coupons are adjusted based on SPEI SPEI, Standardization Precipitation Evaporization Index. That's why these kind of approaches are very important to understand before one does a financial modeling around these kind of bonds and parametric insurances. Then ESG reporting as per SASB and TCFD disclosures. One of the important, again, taking back to the use of the artificial intelligence and GIS, let's look at some of the platforms such as FAOA.org. This is a very, very popular one. Here you can go around, you can play around with your, all kind of information that is there. You can do calculators, you have a diagnostics tools. So let's take the case of this one, Global Water Information Aquastat, and it takes you to this informational tours, and then you can go around, you can look at the maps, you can look at the country profiles. Another one is, what it does is actually when you look at the country profiles, it takes you here and you can look at, say, any one of the countries. Say, let's take the case of Madagascar in 2016, what happened in terms of the drought, and it gives you a complete statistics you can look at, which you can get it again from this, platforms. You can choose your language. I've chosen English as a language. As per your requirements, you can do that. You can see out here what is happening is the pressure on the water resources, world. I've taken the area of world. Again, if you can look at it, landlocked developing countries, it will give you a list of countries such as Burundi. Let's take the case of Burundi itself. Net food importing developing countries. It is all kind of information that is there over a time zone. So 2022, if you just want to look at it, what is the wastage of water and other factors that are there. This gives you a complete understanding of, the parameterization of various kind of aqueducts and aquaforests. So you can play around with this. You can also look at the maps that are there, which is very popular, very, very important in terms of the GIS platform. So if I was to just open up this one, and if I was to open up the platform itself, the GIS platform, here you have it. And you can look at the major hydrological basins. This is as per the global SDG. So if we come down to India, you can clearly see the various hydrological basins and why the geopolitical tensions are becoming very important, of the financial implications. And it's also giving you, if you see that as I hover around, it is also giving me the lat longs and across the world. You can look at it in terms of map, where you look at a 2D or a 3D structuring. What about the analysis? What kind of analysis results that you need to look at? You can explore your data as well. Like, say, if I was to take a hydrological basins global, or you can look at hydrological sub-basins global, SDG 6 basin maps, So that again brings me to a complete understanding. I can add, I can split the data, I can play around with this, I can look at what is the opacity of the maps, how much it is, what is happening out here. So if I click on this thing, it gives me a complete understanding. This is what is another very popular one. Then there's another one called as a droughtmeter.unl.edu. So let me just open that thing out here, droughtmeter.unl.edu. And this is right now in terms of the US itself. So here it gives you a complete understanding regarding the various kind of impacts, intensity for the US itself. They have divided up into various zones, and you can see the impacts that are there. They're also covering the various island nations, island states that they have at any given time period. You can also download your data, you can download your maps and make a comparative study. So these are very popular ones. These are very popular platforms, I would say, that one should definitely look at. It gives everybody a very clear-cut view of what is happening. And on the drought matrices, how do you calculate it? How these parameters are integrated to figure out the various indices that you need to take care of. So we're going to be now talking about another interesting thing, and that is agriculture-related stress, and how do you measure the indices? How do you quantify your climate risk in terms of food and security and the finances? So basically, as per FOA 2021, by 2050, climate change could reduce crop yields by about 25% in vulnerable regions. And this is a very large number we're looking at, because why is this important? Why do we even need an agriculture stress index? Because agriculture is highly climate sensitive, and any small deviation in rainfall or temperature, it's going to have a cascading impact on the food supply, your commodities market, your rural economies, your the portfolios of the banks which are exposed to your agriculture, agri-techs, the insurance companies, and everybody else. So stress indices, which has been integrated with the real-time data. And here is the importance of, again, the data, the importance of GIS as a technology, and the importance of artificial intelligence is becoming very, very important. So any real-time data on temperature, soil moisture, vegetation, health to predict the yields risk, this is why these actually matters. And as far as the farms to finance is concerned, so this agriculture stress index actually provides a quantifiable climate signals which will be integrated into a financial risk models across the world. This has actually been happening of late, and so the insurers, they're using ASI, which is also called as agriculture stress index, to price their agricultural insurance because they're trying to reduce the adverse selection. And therefore, the investors and the lenders are also applying this agriculture stress index to guide the capital allocation towards the agricultural business or agri-businesses and climate resilient infrastructure altogether. The policy and ESG implications are also becoming very important because it is supporting your early warning systems for the governments so that they can plan the subsidies and plan the disaster response appropriately so as to have the relevant planning regarding the food supply chain for the food imports or the export markets, and the green bonds or the ESG funds, they have also been tied up to the improvements of agriculture stress index, scores, because then they're able to measure the performance metrics. And then that relates to the enhancement of sustainability linked loans, because then you are linking your repayment conditions to create a climate resilience in agriculture altogether. And that is how you are bringing in actionable data for risk management and the agriculture, using the agriculture stress indexes so as to transform your climate uncertainty into the agri-tech business or agri-tech market. And this is no more about food insecurity inflation. It's about integrating your agriculture stress index into the climate finance itself. And this is no more an optional, but it's very much an essential part of it, Therefore, you have this, you can go to this popular website by FAO, and this will take you to this very good website where they're talking about various kind of data that you can look at. So let's take this case of near real-time data. So they're actually feeding data about 10 days, and you can also look at the various seasons. So here we have selected, 2nd of August 2025, and see what is happening out here. So you can clearly see that the agricultural stress index, how it is being measured. You have the greens and the blues and the reds appropriately, which is actually measuring your ASI in terms of the percentages, and the drought intensity is also being measured. Because now if you look at it in India, it's a very big issue. The country is flooded and they got a good rainfall as well. So you can look at other factors. You can also look at the progress of the seasons that is there, how it is progressing. So if the progress is normal, is it like stressful at any given time period? A pretty good website to visit. And interesting thing is you can also look at it from the perspective of a country as well. So let's take the case of India as a country. And when we play around with this thing, it will take you to this map, and you can look at it, and you can see what is happening out here. So you can look at a country level as well. Let us take the case of India as a country, and let's see what's happening in India as of 2nd of August 2025. This is the latest information / data you're looking at. So your first decade and your second decade, how is the progress happening? Then how is this is August 2025 to July 2025 to June. So it is giving a pretty realistic real-time picture of what has been happening. So as the country moved from extreme heat conditions, you can see the change of the blue to the greens that has been happening. And now it is very, very highly available on the green side, because that indicates the kind of seasonality factor. You can also play around with the precipitation indices as well on the same platform. A pretty good and a pretty interesting, information / use of data, real-time use of data and the GIS and agriculture stress indices. And that also brings me to another point, is about composite climate risk index. That's another one. Because what happens is it is not a single metric that is going to be telling you the entire full story, and that is when you need to bring in the complete unified climate risk signaling, because composite climate indices is reducing a basis risk by 40% comparable to the single hazard as per the again Swiss Re 2024 reports. If we observe very closely, it's a composite approach because it's taking the simultaneous stressors like your energy demand, your agricultural losses, your infrastructure shocks that are there. This index actually turns the fragmented hazard data into a single actionable signal for capital markets, for insurance design, for ESG resilience, so that you can have your payouts based on when your CRI or composite risk index going greater than 0.75. So see anywhere there CRI greater than 0.75 is going to be a payout factor. Now, if we look at it, the question happens to be how do we calculate that? So CRI is multiplied by 0.4 into normalized drought scores with this formulations. And they have also mentioned when it is normalized, what is your drought scores, your HDD scores, and cyclone severity. And that comes into all these pictures will flow into your composite CRI structures. So again, if I was to take your the role of the data and the AI into account, so we'll just go down to this website of the World Bank, data.worldbank.org's topic. I have just taken any of the topics. So this is one of the topics that I've taken out. So you can look at the way the parameters are moving around. You can download the data. Here, if you look at, I have taken, say, arable land. I can also look at arable land per hectares. Or say, let's take the case of forest land for everybody's understanding. It becomes easier. So across the world, how it is changing. So you see that it starts off all the way from 1992, it's about 33%. It's come down to as low as 31%. So there's been a drastic drop. And this is as current as 2022. Also, interesting point is to note is that you can download your data into a CSV or an Excel or file format. You can look at it from the various countries' perspective. So how has been the change been? Say, take the case of Albania, which has been up and down over the time period. Let's look. So, if we were to take the case of India, let's look at this. There has been an increase over a time period, and right now we're about 24.4% coverage in terms of the forest land. So this is like as good as particularly world average. This is a very, very interesting factor, the composite climate risk index, and this is where one can look at various kind of data. Again, let me go taking everybody back. You can look at various data formats that are available, various types of data that is available. You can play around with it and you can see what is happening. Second point that brings me around is this cyclone and extreme event matrices. How will you measure your volatility to price indexes? Because A1 categories, increase in cyclone intensity can multiply by economic losses by about 3 to 5%, because you have cyclone index, various matrices that need to be taken into account when you're trying to calculate these things. So you have cyclone intensity index CII, which is your weighted average over a spin speed, and then you have accumulated cyclone energy, which is about total storm energy, storm surge index, SSI, which multiplies your surge height into exposure of the coastal areas, because you need it for parametric flood insurance, and extreme weather probability, EWP, which is where you're looking at in terms of the probability of the threshold and looking at it. So anytime the CII is rising by, let me just repeat, it is rising by 0.85 on a scale of 0.85 on a scale of 0 to 1. That's where your cyclone is making your landfall, and your parametric insurance payout of about $50 million when the CII is greater than 0.8, and your cat bond steps up from 5% to 8% under the same threshold levels, and the GIS overlaying showing about 30% of insured assets within the storm surge zone, which is informing your future premium pricing factors. Because here the cyclone and extreme event matrices, they are giving you the characteristics of the storm behavior, the financial impact of the potentials, so as to have essentially for pricing of the parametric insurance, designing of the catastrophe bond, the studying of the strategic stress testing of the ESG portfolios. And primarily the cyclone and the extreme events matrices, they turn the catastrophic uncertainty into a tradable, hedgeable and transparent financial instruments, so as to gain advantage over the marketplaces. Next point that we need to cover is about the multi-hazard climate index, which is from fragmented matrices to a unified financial signal, because integrating hazards into composite index, reducing a basis point by 40% and improving your capital efficiency by 25%, as per again Swiss Re 2024 index that we're looking at. That's where if you look at MCRI, multi-hazard climate risk index, it actually counted based on this formula where you're looking, basically you have got these drought, SPI, PDSI, SPEI, which we discussed a few minutes ago. You have temperature extremes, HDD, we discussed this in about a couple of classes ago. Then you have cyclones and storms, cyclone intensity index, ACE, storm surge index. So let me just go back to this thing. This is what we were talking about. So all of them are combined together in a formula to give you an understanding of your MCRI, multi-hazard climate risk index. That's how it's calculated, because it's calculated on a score of between 0 to 1, and it's a single and it's an actionable index because it is feeding directly into your parametric insurance, your catastrophe bonds, your climate value at risk calculation, something we had discussed at the very initial stages of this lecture series. Why is it hazard, this integration important? Because you have the fragmented matrices right now, and they're mispricing your financial instruments, because you have the drought matrix, say SPI, which is about 2.5. It may coincide with a severe cyclone with CII 0.9. So in coastal agriculture, then you have HDD anomalies, which is spiking your energy cost during the post-disaster recovery. And you have the MCRI, multi-hazard climate risk index, which is integrating or unifying all these risk scores into portfolios for sovereign bonds, for parametric insurances, for ESG reporting. Because multi-hazard climate hazard risk is transforming from your droughts, cold waves, cyclones into a single financial language and enabling better hedging, pricing, resilience planning. So that there's another very popular platform in this regard that one needs to look at, and that is your CME group. You can again go here. You can see the futures and options that are being traded. So you have the CDD July seasonal strip futures, as we talked about. What is the volume? How much is the open interest we're looking at? You have as I play around with this again, which is most popular at this time is London CAT. Then we can also, on this website, we can also look at all kind of options, which is the most popular option at this time period. The name, which is the clearing index, exchange, volume, how that is being traded. So you can play again with the various volume indexes. You can change around, see what happens, how much is happening, what is happening. And this is a very, again, a popular way of calculating your scores across the board. That's where multi-hazard climate risk index becomes very, very important. It's a very important scoring, I would say. All of the participants to please understand this thing. That another thing that we're looking at, because a large population would be moving towards the urban centers now. So urban stress matrix becomes very important, which is about measurement of heat and floodplains across the financially critical cities. So you have the flood susceptibility scores, FSS, and you have integrated financial, how do you integrate the entire thing? So you have the flood susceptibility scores is about the probability of urban inundation, integrating it with the hydrological and infrastructural factors. So you calculate it based on rainfall index, intensity index, drainage capacity ratio, and imperativeness of the surface fraction. And using this formulation is what you get, and you finally you're able to do your parametric payouts based on FSS, which is greater than 0.8, and your municipal resilience bonds, which are where it is going to be having a higher coupon spreads over the sovereign cat bonds layered by FSS. That because any urban stress matrix, you are looking at in terms of your quantification of indicators, which is measuring your cumulative stress on cities due to environmental hazards, infrastructure fragility, socioeconomic vulnerabilities, how will you design to support your green infrastructure finance, your urban resilience bonds we talked about, the municipal bonds. What about the ESG urban portfolio stress testing? How will you do it? And any urban stress scores, 0.7, it's a big issue because UHI of anomaly globally is about 0.8, AQI 0.6 is a big problem statement looking at because urban matrices of allowing financiers, insurers and policymakers to quantify and the price the true cost of the climate and social risks that are there in cities, turning these invisible pressures into an invisible signals. That brings me to another point is about what are the kind of platforms you look into. So look at mynasadata.rc. This one, it takes you out here and you can look at the urban heat that has been created by, they have mapped it out for US at this time period. You can clearly see the east coast and the west coast are the ones that are having the maximum amount of urban heat compared to the middle part of the US itself. Another one is Earth NASA data, where you're looking at human dimensions of the heat. And here, when we go to this thing, you can look at it from the various spheres. So let's take one case. I have taken it earlier. Let's play around with this. So let's take the case of atmosphere. You can select category. I'm taking aerosols. You can choose your data. You see, it's also being uploaded, and over a time period, say I am taking two, I would rather take the latest one, say 2025 to about the month of say May. And how does it look like? Well, the map is going to be loading because there you can clearly see the multiple layers. So you have the equator and the prime meridians and the latitudes and longitudes and the state boundaries, country boundaries. All of them have been layered together. You can also look at it in terms of maps. So here you see the major, if you look at the Earth's urban stress, you see on the northern plains of India is becoming a very big problem, hot statement. Similarly, in China, in the eastern part and the northern western part is another one. The northwest part of the Africa, the other areas of this Middle East is another. Earth, big urban heat is becoming. So these are the ways you can play around. Again, you can link it to download your data. You can play around with, and they have been powered by the Google engine. So it's a pretty good website to visit and understand what's happening in this area. And that also brings me to another point, and that is about parametric indices, which is another very important point, and which is turning your climate indices into an actionable automatic payout triggers. How do you do that? That brings me, because you have parametric insurances and catastrophe bonds and weather derivatives and urban resilience bonds. Because parametric insurance can reduce your disaster recovery from 6 months to 6 days altogether. This is as per World Bank 2023 reports done study, because they're looking at various things, like looking at new rainfall index, to trigger thresholds, to payout, to cat bond coupons, to GIS linkages. They have combined it out because you are trying to quantify the threshold based on a certain objective climatic matrices like your rainfall, which is greater than certain limits of XMM, say. You have wind speeds which is greater than Y knots, and then you have the difference from the traditional insurance because there is no loss assessment of payments. They are based on triggered based payments. So they use the heating degree days, HDD, cyclone intensity index, CII, standardized precipitation index, SPI, for droughts, flood susceptibility scores, FSS. And again, the role of artificial intelligence and GIS becomes again important, because machine learning based approach is going to trigger your thresholds based on historical loss correlations, and your neural networks based advanced deep learning techniques can forecast for your near time hazard evolution for the dynamic pricing. Your GIS can give you an assets exposure zones, while it is able to generate your weighted composite indices for multiple peril triggers, and the blockchain is going to publish the hazard readings in immutable oracles in terms of enabling of the instant settlement for your insurers and cat bonds. So the parametric indices actually converting your raw it's about converting your raw weather data into feasible financial goals, so that's to make it resilience, so as to make it trackable, scalable, and measurable. That's the most important point. Another thing that we need to take care of. So another thing that we need to look at is from matrices to markets. How is it going to be paying? Merging of the multi-hazard climate risk indexed with parametric triggers, because integrating multi-hazard climate risk index with parametric structures will cut the basis risk by 40% and double the market liquidity as per again Swiss Re 2023. Here we are looking at again parametric insurances to weather derivatives to other urban resilience bonds. And when we are trying to do this thing, we calculate our MCRI, which we talked about a few minutes ago, and then we add the parametric layer, which is defining a payout on the bond, which you are where MCRI is less than 0.5, no payouts. It's between greater than 0.5 to less than 0.7, the partial payout about 50% notional, and anything greater than or equal to 0.75 is full payout with cat bond setup. So, an example has been given out here, so based on the various parameters like SPI doubt, HDD anomaly, cloud, cyclone intensity, and UHI and FSS, because the catastrophe modeling models are turning the climatic chaos into risks which is becoming a tradable financial instruments, making resilience, measurable, as I said, investable and accountable all the time, because it is defining your probabilistic hazard curves, which is over a 1 in 100-year cyclone. Take the case of about 250 km per hour. As a wind speeds. This is just an example we're talking about, and how will your AI-powered engines be firing, and which will be mapping to your geospatial systems altogether on the basis of spatial mapping to powering of the matrices, because you need to have CII, you need to have SPI, standardization, precipitation index for drought, your flood susceptibility risk scores, FSS, because based on these things, you'll be combining your physical assets to financial exposures, to socioeconomic exposures. Let's take the case of this climate guide, ucarc.edu. It's a very good platform to look at and gives you very crisp indices. Let's take the case of El Nino and La Nina. And, if you look at the drought, then it's going to give me an index out here. I can play around with any, or I can play based on the guidance, and then I can apply that and see what happens. Is give me a complete understanding from drought atlases, from where 3 rings have been formed, to standard precipitation evaporation index, SPEI. So as I open this thing, it gives me an understanding of what SPEI is all about, to the key strengths, data accesses. How will you do that? You can download your data access based on certain data sets that are popularly available across the board for the platforms that are there. What about the next one, that is catastrophe model, which is a very important point, because you're trying to now quantify your risk, and you're trying to use the hazards and exposures and the vulnerabilities all together. When you combine all 3 or 4 these factors, you get a complete catastrophe models. So a 1% increase in model vulnerability can raise a catastrophe bond risk spread by 30%. That's what, as per Munich Re 2024 reports, because when we try and calculate the vulnerability function, the damage curves, we are looking at a damage ratio, which is talking about the probability distribution functions in terms of which taking the hazard intensity and the asset type into account. The high resolution hazard maps, they're not only visualizing your climate extremes, but they're also giving you a foundation for pricing of the insurance, the structuring of bond, the direction of the capital, then resilient infrastructure that needs to be taken care of. The formulation is in terms of it's a very simple thing, your hazard and the exposure and the vulnerability, they're all mapped together to give you a complete understanding of the pricing of the models that you're looking at, vulnerability functions, the curve damages. This is based on your annual losses to probable maximum loss to tail value at risk. The process of hazard mapping is important because it is giving you a geospatial representation of the climate hazard using satellite imageries, using hydrological models, the training of the data, the purpose, mainly to identify what, where, what has happened, to what degree the assets have been damaged. So let's see the case of floodplains, what kind of digital elevation models we're looking at, the river discharge models, to rainfall runoff analysis, which is giving you a flood depth grids and the return period maps, to wildfire zones, vegetation indices, to fuel load data, to fire weather indexes, FWI. All of them combined together is giving a complete picture around this thing. If you look at another website, this is preventionweb.net, if I was to take you out here, it gives you understanding of what this data is all about. How do you map it out? You can look at the global risk data collection. So I've taken the case of multi-hazard with flood and environmental factors. You can also look at multiple things like drought and earthquake and flood and situations like volcanic and marine and industrial failures, and the environmental factor or the extraterrestrial or the geohazard to biochemical. That will give you a very good understanding of the kind of data points that we're looking at, what are the kind of clustering, what are the kind of multiple hazard. Again, very popular ones. If I was to take a risk scoring tool out here, it gives us a very good understanding of the various risk scoring tools you can choose on the map, and it will give you year-wise. You can play around with it. Again, it's a GIS-based approach, which is giving you out here. It is generating your risk maps as we go about. So see that? It gives you a complete understanding. See, what you're looking at is the case of Southeast Asia. In Southeast Asia, how will it look like it by 2025? So if I was to increase this thing by, say, 2090, how would Southeast Asia be looking like in terms of the risks factors? What about if I was to look at it in terms of smaller areas, smaller time zone, I would say in the similar area? You see the impact is again changing altogether. This is where the catastrophe modeling becomes very, very important for the entire parameterization of various financial instruments across the board in terms of ESG analytics. One other point that we need to take care of is in terms of the hazard mapping. You're turning the climate extremes into spatially recognized, quantifiable measures all over the place. And, that is where you have a situation where you're trying to flood, where you're saying the flood is not just water, but it's about a wildfire, it's just about fire, there's about spatial financial shocks that are waiting to be mapped. Very important point. So any high resolution hazard mapping will reduce your portfolio level risk to uncertainty to about 35%, again as per Swiss Re. How do you do that? So you calculate your expected loss based on the floods, the wildfire and the storm surges, and which is going to give you a pricing of the bonds model, because every flood modeling is coming 1 in 100 years flood depth model you're looking at to across 1.5 meter across 30% insured. What about the wildfire probability? 5% annual changes in ignitions affecting about 20% of backed assets, so about storm surges about 3 meters probability to about 2% annual losses. When you combine all these factors and you feed into the formulae, this is where you get your hazard mapping indices. And one of the popular approaches that we need to take care of the flood plains in terms of digital input, so as to get your digital elevation models where you're able to do your river discharge models, the wildfire zones such as data inputs in terms of vegetation indices. Again, AI and GIS based approaches are very popular. So if I was to use an example in this regard, let's take this platform of this one, nhcnooa.org. It takes me out here. See, you can have a introduction to the risk map. You can have an interactive map viewer to technical description. I have just clicked on it a few minutes back on this storm surge risk map. It takes me out here. You can also click on it. It'll take you to the same thing. It'll take you to this thing. And it is here that you see your Hawaii and Southern California and whatever areas you're looking at in terms of your the risks that are there. I've used this thing as an example purposes. You can also look at from the West Coast side. You can look at what kind of data you're looking at, the Hawaii category, and the Gulf, East and the West Gulf of this thing is giving you less than 3 feet above the ground to greater than 3 feet above the ground. So they've mapped it out very beautifully in terms of color coding so as to understand. And you can also look at it if I was to reduce this map factors. You can see that. So here they have played around with it very beautifully, and that's where they've been able to do the hazard mapping, and where they're turning the climate extremes into spatially quantified data. If I was to again increase it, here it is. So they have right now used about 4 different areas altogether. If it is less than 3 feet above the ground, what areas would be impacted? This is where we're looking at. Anything above 3 feet above the ground, we are looking at the various areas. So that brings me to another point, and that is expected loss index and the multi-hazard climate risk index. How do you do that? You have these are the formulations we're looking at. I will not go through this thing because it's a very standardized approach that is there. We've been discussing about it for some time now. And that, and what about the, I'll bring it to the end to the final point, which is about use of blockchain for parametric insurance, because smart contracts are enabling a parametric insurance that can reduce your payout time from 6 months to 6 hours. That's a huge, huge drop from, you see that, as per World Bank 2024 report, because essentially they will define the trigger, they'll fetch the data, and they'll write the root code out there, which is going to be executed fast. That's where, you know, the smart contracts, the self-executing code on the blockchain, it is going to automatically trigger the payout based so as to remove the loss adjustment delays and that reduce your risks that are there, the disputes in terms of disputes, because you need to look at it from the agriculture sector, which is having a drought payouts. How do you do that for the policy purposes, to about saving the $5 million in terms of drought insurance from farming cooperative, to triggering of the rainfall, to event-based GIS and AI-enabled systems. So smart contracts, they are actually turning your climate data into the capital flows, making them again resilient in terms of faster, cheaper, and more accountable and more trustworthy for every participant, whether it is the government, whether it is institutions, whether it is individuals altogether. That's all from my side on this lecture series, in the 6th lecture of the lecture series. My name is Atul Tripathi. I'm an honorary adjunct fellow at National Maritime Foundation. Thank you.